Assalamu alaikum warahmatullahi wabarakatuh. Welcome to another computer science lecture. In our previous lectures, we have done section number 7.1, 7.2 and 7.3 already. So today we are going to start section number 7.4. I hope you guys are doing good. And without further ado, let's start. Okay, this we have already done, and here we go. Section number 7.4, the standard methods of solution. Now we have basically 5 standard methods of solution: totaling, counting, and then we have maximum, minimum and mean, and then we have the bubble sort algorithm, and then we have lastly we have the linear search. So let's have a look at all of them. The first method on our list is known as totaling. Totaling means to keep a total for all the values that have been input. It means whenever you run a loop, in order to take a series of inputs or a range of inputs, then you just keep on adding all of them together into a single variable. That is known as totaling. This usually happens at POS counters, point of sale counters in supermarkets, where all the items on your bill are totaled into a final amount or the net amount of the bill. How would you write a pseudocode for totaling? Basically, whenever the examiner asks the question, then you don't just have to give explanation, you have to give 2 or 3 lines of code as well, means pseudocode as well, in order to score the complete 4 marks. So this is how you would write: declare total counter marks as integer. For counter 1 to 30, or it can be 1 to 10, 1 to 20, 1 to 50, whatever you're comfortable with. This is just an exemplary code. Input marks, total equals to total plus marks. Next counter, print total. That's it. If you are writing for 3 marks, then you can skip this line. You can directly start from here and end it here. Just these 4 lines are also enough. Or if you just write this line, sometimes in mark scheme that is also acceptable, but you have to give this explanation. Next we have is counting. It is the process of counting how many times a loop has run. Basically, it is the process of keeping a track of how many times a loop has run, no matter what type of loop it is. In the process of counting, we always use a counter variable, even no matter it is for loop, it is while loop, or it is repeat loop. So an example of counting algorithm can be: declare pass count counter marks and integer. For counter 1 to 30, input marks. If marks is less than 50, then greater than 50, then pass count equals to pass count plus 1. Next counter. Over here you can take counter as an example of counter or counting, or you can even highlight pass count as an example of counting, because it is also keeping a track of something. It is keeping a track of students who have passed on their test. Counting is also used to count down until a certain value is reached. For example, checking the number of items in stock in a supermarket. And how do we do that? We, instead of +1, we do a -1. Numbers in stock equals to number in stock -1. If number in stock is less than 20, then reorder, means run a function of reorder so that an email goes to the relevant vendor or the store manager is notified. And if the third standard method of solution is maximum, minimum and mean, means the calculation of maximum value out of a inputted range, the minimum value, and the mean or the average value. Finding the largest, smallest values in a list are 2 standard methods that are frequently found in algorithms. For example, finding the highest and lowest number out of all inputs, finding the least marks and the maximum marks gained in an exam, finding the most expensive item and the least expensive item, or finding the highest temperature or the lowest temperature. and so on. Mean is the calculating of average from the inputted range. In such algorithms, a loop is always run as there are always a range of numbers to be input. There is never a single entry, because you cannot calculate a minimum, maximum or average out of a single number. Now how you can do that? This is an algorithm to incorporate all three things, and I have included comments as well. Declare max marks, min marks, mean, count, marks as integer. The thing you have to remember is if ever you have to calculate the minimum or the least or the smallest out of a range, whenever you have to calculate the minimum value, always initialize the variable from minimum or least value with a bigger number. Otherwise the logical comparison would fail. And if you have to calculate average, always initialize or set your count or counter variable as 1 instead of 0. This would help in division, means calculating of mean. We'll see how. For count 1 to 30, input marks. If marks is greater than max marks, this is the starting of a conditional statement. Then put the marks which you have just entered into maximum marks. Else if marks are less than minimum marks or min marks, then put the value of marks which the user just entered into minimum marks. Now over here, if this value is 0, and let's suppose that marks for test are from 1 to 30, and the lowest marks a student got were, let's suppose, 5 out of 30. Then if the marks were 0, if they were set as 0, if they were initialized as 0, then this check that if min marks are less than min marks, then 5 would never be less than 0. So that means at the end of the program, when you print the values, the minimum marks would be shown as 0, which is wrong. You should get 5. So that is why we initialize minimum or the least value with a very big number, so that logical comparisons or mathematical comparisons can be made easily. And since we started 2if, so we are going to end 2if. Then total equals to total plus marks. We have to calculate the total for finding the average or the mean. Next counter. Always remember, totaling always happens within the loop, inside the loop, and not outside the loop. But the calculation of mean or average, that we do outside the loop. Now since the benefit of initializing count as 1 is that I can simply use its value in the formula for average. Average is sum of numbers divided by number of numbers. Count is the number of numbers, and total is the sum of numbers. So I can simply write mean or average equals to total upon count. Otherwise, if I had initialized it at 0, then I would have written it as total divided by count plus 1, or total divided by whatever value I have written over here, 30, 20, 60, whatever it is. Then we just simply print our results, print max marks are, and then the variable name, minimum marks are, variable name, average marks are, and the variable name, that is mean, end. If you have to do any one of these, then you can simply omit the part. Normally you have to calculate maximum and minimum together along with the average, but if examiner asks you to calculate any one thing, then you can simply use the part for that and omit the part for the next other for the other two operations or calculations. Always remember to initialize minimum with a very high value and initialize count as 1 if you have to calculate average or mean. If the largest and smallest values are not known, an alternative method is to set the maximum and minimum values to the first item in the array. Let's suppose you have to search an array and you have to find what are the minimum and maximum values in a given array. So what you can do is simply set the max marks and minimum marks with the value of whatever is at the first position of that array. For example, max marks equals to marks 1, marks would be our array, and minimum marks also as marks 1, and for count 2 to 30. In that case, if you are following this method, just remember to run your count from the second position and not from the first position. Rest of the logic remains the same of calculating minimum and maximum, and if you have to calculate mean, then you'll follow the same procedure as shown over here. Mean equals to total upon count, because count is going to have a maximum value of 30. Okay. Next we have is something that is linear search. A search is used to check if a value is stored in a list, performed, or in an array. It is performed by systematically working through the items in the list. For example, searching for a name in a list of student names where all the names stored are different, or for example searching for marks out of a list of marks, or searching for a specific roll number, etc. This is a very simplified and rather easy algorithm that you can use for linear search. Declare name as a string, count as integer, and found as boolean. You have to initialize these three variables. You can use marks instead of name if you are dealing with a numerical array, or you have to search a numerical list. Otherwise these three would remain the same. We are going to display a message, please enter the name to find input name. Found would be false, counter would be 1. Repeat, if name equals to names count, this is, we are basically comparing our inputted name with every entry in the array by using this term names and counter variable in the bracket. If name and the entry in the names array match, then found would be true, else count would be count plus 1, so the next entry can be compared. And if until found equals to true or counter is greater than 30, means there would be greater than 30 means 31, so it would end at 31st position. If found means if found is true, if you have found the value, then output name means whatever the user inputted, that name has been found at position, and then counter means whatever would be the value of counter would be displayed over here. Let's suppose you entered John and that was found at the 15th position, so at that time your count or counter would have a value of 15. Sorry, this should be counter, not count, my mistake. This would be counter. So the counter would have a value of 15, so it would write John found at position 15 in the list. Else if found is not true, then output name means John not found in the list, you have searched for a wrong name. If several values in the list are same, such as to calculate how many customers ordered a smoothie or a banana shake or whatsoever, we can also use linear search for that. Choice count equals to 0, for count 1 to length means whatever is the length of your array. If smoothie is equals to dessert counter, then choice count equals to choice count plus 1 and next counter, means if smoothie matches with the stored value in the dessert counter, then you just keep on adding 1 to the choice count, and at the end of the running of loop you simply output choice count, choose smoothie as their favorite dessert. For example, 13 people ordered smoothie on a day. There are 13 entries of smoothie in your list, then it would output 13 chose smoothie as their favorite dessert, or you can add simply the word customer, so it would read 13 customers chose smoothie as their favorite dessert. And remember, if you have to search a term, you have to put it in inverted commas. A string or a alphabetical value, you have to put it in inverted commas like this. Or you can simply input this value into a variable and then simply write if choice equals to dessert counter and so on. You can also do that. Last method, standard method of solution we have in your syllabus is known as bubble sort. There are other sorting algorithms as well, but in your syllabus we only have bubble sort. It is a method of sorting an array in a specific order, either in ascending order or either in descending order. You can do both. It works by repeatedly swapping the adjacent elements if they are in the wrong order. This is basically how bubble sorting works. It's in the first pass it compares first and second, and then second and third, then third and fourth, and then fourth and fifth, and it comes to this. In the second pass again no swaps are made, second swapping is made, no swap needed, no swap needed, and we get this result. Again in the third pass it would again check the whole array or the list one final time, and if no swaps are made, no need for any other swapping, then the loop or the sorting algorithm would stop. Example 1, sorting a list in descending order, and this is the list number 45. It is basically an array 45, 56, 30, 12, 15. Declare count, store, flag, integer as integer. These three are integer. Repeat flag equals to 0. For count 0 to 3, because there are 1, 2, 3, 4, 5 numbers, so we are going to run the loop 4 times. Normally the number of members we have in an array or list, we need we minus 1 from it, and we find out the number of swaps or the number of times we have to run the loop. If num count, num is the name of this variable and count is the counter variable, is less than num count plus 1, means if this is less than this, and this is less than this, and this is less than this, and so on, then put the value in store. For example, if 45 is less than 56, yes, it is less than 56, this is the first value, so this would be num 0. Num 0 is 45, and num 0 plus 1 means num 1 is this position 56. So this would mean, is 45 less than 56? Yes, it is. 45 is less than 56. Then put the value num count, means this 45, into store, and swap the value of num count plus 1 with num count, means this 56 would come over here, and num count plus 1 would have the value of store, that was 45. So this 56 would come over here. I'll show you what would happen. This 56 would come over here, and the 45 would be on the next position. It would be moved, and the rest of the algorithm would remain the same. This is the first swap. And if you have made a flag, then if you have made a swap, then flag would become 1, and if next count, what would happen next time? Now the for value is 1, so count 1 is 45 and it is 30. Is 45 less than 30? No. Then simply next count. So in the second pass we have not made any swaps because 45 is not less than 30. Then we have num 2 and num 2 plus 1 3, means 30 and 20. Again, is 30 less than 12? No. All of this if would be skipped, and we'll directly go to next count. Okay, because this condition does not meet. So that means in this pass no swaps are made. Now we have to compare between num 3 and num 3 plus 1, means that would be 4. 12 and 15. Is 12 less than 15? Yes. Then we would move the value of 12 to store, and 15 would come over here. It would become this, and now we have our array sorted. And if next count, there is no need for next count, then we are gonna go back to repeat, and then flag would become 0, and when flag would become 0 again, the repeat loop would also be ended and end. All of the members of the array have been sorted in descending order. If it was to be sorted in ascending order, we would simply change this operator from less than to greater than sign. Rest of the algorithm would remain same. Again, if we are sorting an array in alphabetical or ascending order and these 4 are the names, then flag count, declare flag count as integer and temp as a string. Over here our temporary or store variable was integer because the array was integer. Now we have a name, so we are going to take it as a string. Again, we have the same formula or the same layout, except that over there we had the variable named store. Over here we have the variable named temp, and we have simply alternated this sign. Over here it was less than, now we have greater than, because over here we are going in ascending order. This algorithm is a little different, but you can still use this as well if you want. These are the two examples of sorting algorithms, bubble sort, and you can follow any of these for sorting your algorithms in ascending or descending order. And that's if you run this algorithm, then your result would be something like this, where all of the 4 names have been sorted in ascending order. Generally, we need to perform one less swap than the total number of items in the list. For example, if a list is of 5 numbers, then we would perform 4 swaps, and that's it. This is all you need to know for section 7.4. I hope you have understood everything. Please do give me your comments, subscribe to my channel, and support me. If you have any problems, feel free to ask me, and I'll see you guys in the next video with another lecture. Take care. Allah Hafiz.